Good evening, everyone. This is Rich Medeiros talking to you from TACO After Dark. Welcome. Tonight's broadcast will be all about HSS, which stands for Hydronic System Solution Software Introduction. But before we get started, just a couple of things I'd like to touch base with. First of all, again, thank you for joining us for this TACO After Dark. A little bit about TACO, for those of you that are fairly new to TACO, we are a 100-plus-year-old company. You can tell from Brett Zerba's opening screen. We actually reached 100 years last year, 2020. So we're actually into our 101st year of being in business. TACO originally stood for the Thermal Appliance Company. And many, many years ago, it was changed from Thermal Appliance Company to TACO. So that's where the name TACO came from. Sorry. It's the company is owned by the White family and is currently headed by John Hazen White Jr. And John has a senior management team led by Cheryl Merchant, who is our global CEO. And Cheryl and her senior management team have done a fantastic job getting us through this COVID crisis and preparing a plan for the future that will make TACO even bigger, better, and stronger in the years to come. So we're very pleased to have Cheryl and her team running the global operations. A couple of quick housekeeping things. We hope that you'll ask questions, type them into the question area. You should have a little control panel that pops up. And if you click on the arrow where it says questions, you can simply type in the question. So just to make sure that our question box is working properly, for those of you that are out there right now, if you could just type into the question area that says, hello, we can hear you, we can see you. That would be great indicator that we're broadcasting successfully. Now, we are recording tonight's broadcast, and you will be able to get a copy of this recording roughly 24 hours from now. So look for it tomorrow or Friday in an email announcement. And also, for those of you that are interested in getting professional development hour credits, also look for that email probably toward the end of the day tomorrow or Friday. And I think I've covered most of the stuff, and thank you for typing in that you can hear us and see us okay. That sounds great. We expect some more folks to be joining us fairly shortly. But we're not going to hold back. I'm going to ask Brett to start the presentation by first telling us a little bit about himself and then get into tonight's discussion. So, oh yeah, let me just say a thing about questions. We will answer the questions. I will act as tonight's moderator, and Brett will actually be doing the presentation, Brett Zerba. And I will be monitoring the questions, and we will answer those questions in real time. I will ask Brett to pause periodically as questions come up, and we'll do that during the broadcast. And then we'll also have some time at the end of the formal presentation. Now, the formal presentation lasts roughly an hour. Would you say, Brett, roughly an hour for the formal presentation?
Yeah, that's pretty close.
Yeah, and since this is the TACO After Dark edition, hopefully you've most of the folks that are listening in have finished their workday or pretty close to the end of their workday, and they're kicking back a little bit, relax. So this is informal. Ask your questions. We'll answer them in real time, and after the formal presentation is over, Brett and I are going to stick around for as long as you guys are interested in asking some questions. When I use the term guys, I'm really talking about women and men collectively as an audience. And the other thing I would say is that we'll probably wrap things up at the latest at 9 p.m. East Coast time in the United States. So That should give us plenty of time to chat, get to know each other, answer your questions, and all that good stuff. So I'm going to turn it over to Brett. Brett's going to introduce himself and then kick off the presentation. Brett, take it away.
Thanks, Rich. Appreciate that. Great introduction. Hi, everybody. Hopefully you recognize me. I recognize quite a few of the names of the folks that have signed in. My name is, as Rich has said, is Brett Zerba. I'm an applications training engineer, applications engineer, mechanical engineer. We wear a lot of hats, like many of us do in our lives, our work life. I've been working with for TACO for 25 years. It's my third career out of after I graduated from the University of New Hampshire in 1981 with a degree in mechanical engineering, and these 25 years have been arguably the best professional parts of my life. Just been a fantastic situation. I can't say enough good things about the company and the White family. And hopefully all of you enjoy getting up in the morning and going to work. And as I do, it is truly, truly a pleasure. So tonight's presentation, let's make it interactive. If you want us to design a system using this software, a hydronic system, shout it out or type it in there, and we'll try. I'm going to show you the basics, and then we're going to take off, and we're just going to keep designing systems. And this software, we've been affiliated with this software for probably 20 years now. We did not write the software. Okay, I do need to clarify that. TACO has a lot of intelligent, gung-ho people, but we didn't write this software. We are partners with the company that did write it, and I'll show you some more information about them very, very shortly. And one of the nicest things about this software is you can download it from our website free of charge, okay? So let's get going. You know, I can yap all night, as most of you already know that, but nonetheless, let's get going here. So as Rich said, the software, it actually won an award. We call it TACO's award-winning HSS software. But the award was given to the software writers, company that wrote it, HVAC Solution, in 2007, I think. I forget what year it was. It was probably a little later than that. But anyways, at ASHRAE for innovation in software development. So they did win an award for that. So we call it Hydronic Solution Software. Some people say HS2, HSS. So it's got a couple different names, you know, like a lot of things in our industry do. And I've said that before. So, and it's a graphical drag and drop system design software. And you'll see what I mean by that when I get into it. And most of the presentation tonight is going to be actually working on the software. I've got 2 or 3 screens and then whatnot. If you were on before the webinar started, you've seen some history of TACO. If we end up a little early, quarter of 9, 10 of 9 or whatever, or if you want to know about it after, I'll go through it and we could talk about it and ask some questions. It's quite a history, and some of you may have read that as it was popping through those 5 or 6 screens. As I mentioned, it is a free download from the TACO website, and I'll show you how to do that. But trust me, it's very, very easy to do. We don't put a lot of things in front of you to stop you from doing it. We ask you to register. I know we require you to register, but most of the people that have trouble, because I get questions, you know, through our helpline about the software. Most of the people that have trouble downloading the software, it's because of their company's firewall. So some of you probably been through that for other systems. It is an executable file, exe file, and sometimes companies firewall, as they should, get really leery about that type of stuff and some of the issues that could cause. So nonetheless, it does need to reside on your computer. So keep that in mind as you go. So work with IT, work with your IT department. And the software creator is a company called HVAC Solution. We're their partners. We've been their partners for many, many years, proudly saying. And they are actually located in Salt Lake City, and a very heady group. It was 4 guys that started, 3 or 4 guys that started. Ben Davis, Alan Nichols and Joe Simmons were the main thrust behind it. And they worked for a consulting firm out there, and they did a lot of design work for the Winter Olympics back many years ago when it was in Utah, in Salt Lake City, quite a few years ago. And a lot of that work was repetitive. A lot of it was very similar for the design work. And so, thinking outside the box, they said, hey, maybe we can come up with a software package to help people design these type of systems or whatnot. At least that was how the egg started, I guess. But nonetheless, that's a little quick history. They are still in business, and they still sell the software. A different version of it. It does the same thing as our version plus other stuff, and we'll talk about that as we go today as well. So what this software allows you to do is design, and people might read this, might see this bullet and say, no way, come on, you can design HVAC hydronic systems in minutes? No way. Well, let's see if I can change your mind if you've never used the software after we work with this. I mean, we need to put in some information. Most of the information we need to put in is loads in BTUs per hour, right? So that baseboard, that fan coil, that air handler, whatever size that is, or what that room needs for air conditioning or heating or whatever, we need to put that into the software. And I'll show you how to do that, right? And pipe lengths, right? We got to tell the software how long runs of pipe are from A to B, and if some of you have sat through our presentation, Rich's presentation on calculating head loss, you know how important that is to know the length of pipe, not just for head loss on pumps, but also for volumes, as we talked about 2 weeks ago, for developing the size of expansion tanks. You need to know the volume, so we need to know the length. So those are two variables that we need to put into the software, the user. And once we do that, boom, all these calculations are done for us. And we can manipulate the calcs and whatnot. So, and I'll show you all of that. It's not cast in stone by any stretch of the imagination. And I can't emphasize this one enough. Very user-friendly. I'm 62 years old, and even I taught myself how to use the software maybe 10 years ago when I was a little younger. But folks nowadays, I mean, my little grandson, he's 20 months old. He's already playing with flipping electronics, right? He'll be using this software in no time. He may not know what he's doing, but he'll be using it. But I think you know what I mean. Folks nowadays are very, very familiar with software and Windows-based programs, and they know how to pick functions up and all of that. So it's very, very user-friendly. Yes, there's videos. Yes, we can teach you. We can train you. We can show you how to use it. But it's amazing how many times after a presentation or a talk with some folks, and I show them the software, or somebody shows them the software, I'll get a file from them that is incredible, better than I could do for a design that they do. And they have a couple questions, and we go over some details, further details or whatnot. But it's phenomenal how far they can take it after a presentation like tonight. It allows us to create a workable flow diagram. And you'll see what I mean by that. But this flow diagram, we can work with it, we can manipulate it, we can make changes very quickly, but it keeps track of those calculations for us, right? The flow and head, the volume, and it shows a nice distribution all on one sheet. It's not perfect, but if you think about a lot of MEP drawings or whatnot, I've got rolls here from projects I work on and you got to go from sheet A to B to C to D to follow the piping. This one here, it's all on one sheet, or one D-size sheet, maybe two. It depends how big the project is. But nonetheless, you can see it in one area, and the floors are attached and whatnot. So, and you'll see what I mean by that as we go. This one can wow the crowd. It sizes and displays pipe diameters on your drawing at a click of a couple of mouse buttons. And it uses ASHRAE standard, hydraulic standard, HVAC standard calculation methods for sizing pipe that we can change and all of that. but boom, you hit a couple of buttons, and all of a sudden the pipe diameters are displayed on your pipe, excuse me, on your drawing. It's really nice, really nice. This question always comes up when we talk about expansion tanks, or many times, most times, and you know, people struggle, our reps struggle, you may struggle, you know, the real answer is you got to do the calcs, right, to get the volume of the system. Well, this software will do that. It'll calculate the volume of the system for expansion tank sizing. You know, you put in some details, and boom, all of a sudden you have that volume displayed for you. You know, Rich and I are proponents of doing the calculations, right? And I know there's other methods out there. People may have some shortcuts and whatnot, and they may work fine for some, but we propose really to get behind doing the calculations, so you have that evidence, not evidence, but that information in your back pocket for your design. And well, anyways, I can't emphasize that enough. It calculates pump flow and head and displays it on your drawing in seconds. You know, what does Taco? What's one of Taco's main products? Pumps, right? Well, this software gives you the information, so you can order the pump from us. Boom, bing, bingo, bango, bongo. You put it right on the schedule, and our rep can get it to you lickety split. So, anyways, I kind of being a little goofy there, but it does it very, very quickly, right? That flow and head that we talked about a couple weeks ago, 3 weeks ago now, whatever it was, in our first session. And very important for us doubting Thomases. The designer, the engineer, the person using the software has the ability to control the design. And what I mean by that is we can override the default values, and I'll show you what I mean by that in the software. As an example, when I put a picture on the screen, an icon on the screen of a fan coil, as an example, well, many of us realize that we've got to calculate some type of or there's a value associated with the volume of that fan coil of liquid in it, and how much pressure it takes, or how much resistance it is going through that fan coil. Well, the software has a value associated with that piece, that icon. As an engineer, as a designer, as a creator, as the person responsible for this design that I'm putting together, I can change that value to the actual number, right? It's an estimate that's in there right now, but I can put in the actual value, and I'll show you what I mean by that. So very, very important. You know, some folks get a little leery when software does too much for us, but we can change that. We can manipulate that. The software also, for many pieces of equipment, can select the equipment for you, right? So, and I'll show you how to do that. So, and let me tell you a secret. All of the Taco equipment is selectable by the software. There's other companies in there as well, maybe not other pump companies, but other companies for boilers and chillers and whatnot, but we are the exclusive pump company in the software. The software can also almost automatically, with a click of a few mouse buttons or changes in some parameters, create schedules, bills of material, and detailed reports. And I'll show you what I mean by that very, very quickly as we get into a design or two. You can also save the schematic to AutoCAD, not to Revit, but to AutoCAD. So something to be considered there. And it's a workable drawing. And I have seen many MEP packages with the HVAC hydronic, the design that the engineer did as one of their pages in their MEP drawing. So something to think about in that regard. So those are some of the bullets I wanted to at least introduce you to, but you know, I'm going to dive into the software and show you what I mean, and show you how easy it is to use, and maybe get you out of here by 9:05 instead of 9:15 tonight. So what do you think about that? So we'll see. But like I said, if anybody wants to go over the history of Taco by the end of tonight and ask any specific questions, and maybe bring up something about knowing when the Perfecta was introduced, or the wet rotor circulator, or knowing Mr. White. If you have a story about Mr. White, I was able to meet Mr. White when I started. A fantastic man. I've known Johnny since I've been to TACO. But anyways, and then his two boys, both Rich and I know him quite well as well, and we're all learning about Cheryl, and what a great job she's doing for us. But nonetheless, let's get into the software. Let's get going here. Let's get going. Oh, before I do that, I digress. Let me show you how easy it is to download or to get to. If you go to our website, right, tacocomfort.com, right, and you've been here before, we've shown you the products and support and training. But see, we got a little tab that says software. You click on that, click on that, click on that. HSS, you click on that, and then you can download it or look at some videos. So like I said, it does need to reside on your computer. It's not a Windows-based, it's not a web-based program. That could be in the works. We've been into some discussions with the boys in Salt Lake, but nonetheless, currently it is a program that has to reside on your computer. And the actual icon for the TACO version of the software, let me get back to that, is this one right here, this green icon with the white pump right there. Probably should have been white with green, but nonetheless, that's the icon for the TACO HVAC solution software. Here's an example of a diagram that the software can produce for you, okay? And hopefully you can tell very quickly that it's a heating diagram. And I don't even need to tell you why, because the pipe's red, right? The pipe, the drawing is color dependent. The pipe color is temperature dependent. Red for hot water, blue for cold water. And then we got some other colors for maybe a mixture of water or whatnot. But nonetheless, you can see that very, very quickly. And here's a 4-story building, right? So think about this, right? More than likely, all of this information probably would not be on one drawing for a contractor to look at, or the person maybe pricing it up or whatnot. So this is all on one D-size sheet. I happen to this one's saved to a D-size sheet, right? So if I zoom in down here, you can see this represents a couple of boilers down here, some of the little boiler piping. And this is a simple diagram, right? It's just a couple primary vertical inline pumps. I love the color of this equipment here. Nice color of green, green color of money. But hopefully you all realize that's the TACO equipment color. But nonetheless, for most of it, some of this stuff we actually don't have is green. But anyways, we talked about that last week, 2 weeks ago. And you can see the pipe sizes are shown here. In this case, there's that flowing head. There's the gallonage being taken care of or shown on the expansion tank as well. We added some notes here, or the software did, the user did, showing the length. Here's a dedicated outside air unit, and there's the load in there and the flow rates through that as well. Oh, look, you can even, this looks, that's a BV, balancing valve, a control valve of some sort, a control valve for the DOAS, the DOAS unit, right? Kind of makes sense. The pipe is labeled hot water systems, hot water supply, hot water return. And then up here on each floor, you can see we're representing some fan coils. This is a very simple diagram, but nonetheless, you can see all that information there. And look, the pipe diameters actually change, right? As they should, as flow is reduced going out there or increasing in the return. You can see that the software displays that for you as you go there very quickly. So all this information is shown and displayed, and this represents a 4-story building with 12, 15 loads on each floor. Very simple diagram, but nonetheless, you can kind of get an idea of what that is. I always like to show this though. Watch this right here. So right now I've got 57 over 67, right? Roughly 57 GPM, 60 over 50. But watch, what if you got to make a change, right? So the architect makes a change, and so I'll just delete this system. That's free noise making there, and then I'll hit recalculate. And I'm going to show you how to do all this, right? So bear with me. But look, instead of, it already has resized that equipment for us and shown the new flow and head, right? And if you think about what maybe you would have had to do if that the software didn't calculate that for you, you can see how quick that is. And then just because I want to keep the file the same, if I hit the undo button, it'll actually come back to the original design. So kind of crazy how quick that can go back and forth. And then just so you know, this is obviously a heating diagram. You can also do chilled water diagrams as well. And really, any HVAC hydronic type of system, so a heat pump system, changeover system, all cooling, all heating, combined systems or whatever, you can utilize this software to do ground source. You can actually look at some wells here, and I'll show you some heat source sink. I'll show you some of that as we go. So you can do some chilled water, and you get the same information, right? In this case, we're showing a water-cooled chiller, right? You can see cooling tower here, and you know, just a couple of pumps tying in there, and then there's your main pumps for getting the water distributed. So you can kind of get a flavor for what it does or allows you to do. So just keep that in mind. And then before I start designing a system and showing you how easy it is, check this out. If you go up to File, click on Open Example, there's a whole host of examples in here that show you a lot of, give you some ideas. If you ever if you get stuck or you want to think about something, so maybe something like hospitality, right? The hotel work or whatever, school, K through 12. You can get some residential projects. You can see some of that. Let me take the furnace model. Let's see what that actually looks like. You can kind of see this is more on the air side, but nonetheless, you can get an idea, and we'll talk about that a little later as you go, so you can get an idea. But the reason I like to show you this open example is because if you click on details and detail sheets and hydronic details, and there's a bunch of other details in here as well, metrics, so this software can do, you can do it in a metric design. And I'll show you that. That's pretty easy. But if I click on hydronic details, you get a flavor for all the details that are available in here, right? So and you can copy and paste this. You can use this for a presentation, right? I can copy this. And I could paste it into a Word document, into a PowerPoint, or onto my design, or whatever. So, and it gives you some ideas for pump details, maybe some fan coil details, water-cooled chiller details, boiler piping details, all different types of stuff. Heat exchanger, this is a shell and tube, but nonetheless, you can kind of see some of the details that are available there as you go. And then here's your legend. Every once in a while, someone will ask a question. Maybe your company has a different picture for a gate valve. Can I bring that into the software? And the answer is no, you cannot. Not a lot of answers are no to questions, but that is one. You cannot override the picture that's shown in here. So you can do a legend, or if you want, this is this is kind of neat. This shows you the sizing of pipe and the flow rate ranges that the software is going to utilize. You can kind of see that there, and again, that's right out of the standards. So nothing's out of the ordinary there, and you can change that or manipulate that as you'd like. So I do like to show people some of the some of these details. Every once in a while, I'll get a call and from a contractor or somebody, and he says, hey, I got to do I got an expansion tank, it's kind of old and I'm replacing it. You got a recommendation on piping? And so I go like this, I copy this and I go to an email and I send them an email with that picture on it. Come on now. Oh, well, why did I do this? But you can see if I put, boom, there it is, and I can send that to anybody very, very quickly. So you get an idea, and then we could talk about, it's pretty self-explanatory what most of these call outs are, but we could get into some of that details with them if we had to or whatnot. So, some stuff to consider there as you go. All right, so let's get into designing and showing you how to actually use the system. Rich, we got any questions or comments? I've been yapping for a while. I haven't really done too much, but we
Well,
in good
actually,
shape.
we had a quick question. Does this work on a Mac system?
Uh, it's a Windows-based program, and not directly on a Mac, but there are ways to run Windows programs on Macs. Not that I know how to do that. I'm not a Mac user, but do you know how to do that, Rich? I'm a little
I believe
illiterate.
you can. You can get a Windows emulator for your Mac, and then you can run Windows software. But I haven't used a Mac in years. I actually did have one many, many years ago, but that was when they first came out. So
That's a big word, emulator. That's
emulator, yeah, it's got
yeah.
more than one syllable.
Holy moly.
Holy moly.
Yeah.
Actually, and then there was a comment. I'm not sure if I understand the comment. I'm going to read it to you. It says pipe size chart has a glitch on minimum 0.575 flow. I wonder if, let's take a look at that that
Well, look,
pipe
maybe
chart.
we've got to. I love when we get things that
Yeah,
need to be
find
corrected
stuff
here.
that needs to be fixed. What is that? What's going on there?
Right there. Is that what he's talking about?
I think
Point
so. 0.75
three.
inch. The flow is zero point 0.6 to 3.5 gallons per minute.
So
He
maybe
says
that
that
should be
there's
1.6, right?
yes.
Or
Look at that.
1.7.
Yeah, it should be
Thank you
1
very
point. Yeah,
much.
that's what he says.
Yeah.
That's from
Yeah.
William.
All
William, do
right.
they call you William or Bill or
We're giving them a gold star because
Bill?
they're
So
they're.
Bill, yeah. So Bill, thanks for pointing that out. You know how many times Brett and I have looked at this and we've never
Yeah.
seen that?
Yeah.
You know, when you get another pair of eyes looking at something, you get all
Yeah.
kinds of uh,
And by the
stuff.
way,
So
I don't like using half-inch pipe on commercial projects. So this is what I do. I'm going to show you this just because we're talking about pipe right now, and I'm going to click on. I went to the project property box. I'm going to go this, and I'm going to undo half-inch pipe. I'm going to hit OK, and watch this. Instead of designing a half-inch pipe, it's not going to select half-inch pipe now, and that all changed to 3/4 inch pipe. So there you go. But nonetheless, I'll show you more details of that as we get into it. But thank you
so
very
Bill,
much
you're
for
on the hook now, Bill. We're gonna ask you about every 10 minutes if you see anything wrong. So
I, I'm sure he won't be shy. But
he
thank
said
you. That's
okay.
a
Bill said okay. All
oh,
right.
okay. Good. All right. Back to what we're talking about here. So I've got a clean sheet of paper, right? You can see this here, and this represents a smaller sheet of paper because I'm going to start off with a little design here, and the Takeo version of the software gives you access to the Hydronic and Hydronic 2 tab. All right, the Hydronic and Hydronic 2 tab. So if you want to use it for and the Wizard tab, and I'll show you the Wizard. That's really the bang for your buck. We'll get to the Wizard tab shortly. But the air handler and airflow tab, the steam, domestic, and all of these other ones here. And some of them I don't even like to talk about because there's not a lot of HVAC hydronic equipment on them. You need to talk to HVAC Solution, and I'll show you how to get to their website. You can download a trial version and use it. And as a matter of fact, we have a Takeo Tuesday coming up in August. Wait, what month is it? It's already July. God dang it. Hey, middle of July. Well, you know why? It's been raining since July 1st. We're setting a record in New England. And I live just outside of Boston, well, half hour outside of Boston. And it's the third wettest July on record, and it's only July 14th. So we could be, it's virtually rained every day, and some days inches, not half inches, inches. So you folks in California, don't get mad at me for talking about that. But what the hell was
So
I
Brett,
talking
you know
about?
what that means? That means you and I are all wet.
Yeah, we're wet. We're wet. That's true. That's true. Okay. So, anyways, Hydronic and Hydronic 2 tab. So the Hydronic tab shows you a bunch of pictures here of different pieces of equipment. And if I put my cursor over one of them, and a lot of what I'm doing now is common throughout the software. So notice it tells you what it is, a hydronic boiler. You click on the down arrow, And look at this. Oh my God, there's a bunch of names listed there. And hopefully most of them are recognizable by everybody here. Probably more recognizable to you than they are to me, but that's not true. I know most of the folks anyways. So what that means is you can actually design, and I'm only going to pick the first one, maybe that boiler would be able to be selected by the software. But as you can see, boiler manufacturers aren't their own, the only folks. Not one boiler manufacturer is the only boiler company in here. There's a bunch of them, so you would have to pick that at the beginning if you'd like to tailor that around your design. And then their equipment is selectable, and they're selecting programs tied right into to this program. So you can kind of see that there. Here's some plate and frame heat exchangers. Or shell and tube plate and frame. It says, I should have, if I put my cursor over, it tells you a hydronic heat exchanger. There's an X pump block. That's some of you folks may be familiar with that. That's a Taco product, more for high-end residential products, where it has a couple circulators, so it actually mixes the water temperature, but it has a heat exchanger at the back. So it's actually for snow melt type systems. Where your boiler would be inside, or the hot water would be inside on one side, and then you would have the other pump, the other circulator pushing through the heat exchanger, and you could keep the water temperature correct going out to your snow melt system. So that's the X pump block. I'm not going to get into that too much tonight, but then you can see the other pictures here, air-cooled chillers, a couple of small chiller companies in there, but nonetheless, you kind of get the feel for that. Oh, here's the ones, the pumps. Here's some pumps here and other pieces of equipment. What we talked about last week, 2 weeks ago, Rich, with the expansion tanks. You can see all the different types of expansion tanks listed there. And then a couple of weeks, pretty soon, we're doing a big talk about inline air and dirt separation separators. So that's what these pictures are. And you can see other pictures down here as well. And I did talk about the ground source. The software, you can do a ground source design for it doesn't design the well, it doesn't design the tubes or anything like that, but you can put that information in there and connect it to the rest of your system if you'd like. So maybe if you had a heat pump job or something like that, you may want to show that. So this is how you drag and drop a piece of equipment onto the screen. Very easy to do. You just go get a picture and drag it and drop it on the screen, right? You can kind of see that, how easy that is. And I can get this chiller over here, and I can drag it and drop it on the screen, right? And I think you kind of get the gist there. Obviously you can't see what I'm doing. I'm using a mouse. Actually, it's a wired mouse. People laugh at me when I do classes in front of them, and oh my God, I haven't seen a wired mouse in forever. And it actually has a roller on it. And I find it's a lot easier to use a mouse when I use this software. I've gotten used to using that, so that's what I recommend. And then you can get a picture of a pump and put it on there. And you got the undo button, Windows-based program. You can see all that terminology up here. And probably most of you, if not all of you, know more Windows functions than I do. Unfortunately, Rich and I are Windows challenged at times.
I'm only 26, Brett.
That's true. That's true. Yeah. I tell you, every time we talk, you seem to be going in the opposite direction.
Yeah, I was 27 last week, but no, this week I'm 26.
So what happened? Your air conditioner died?
Yeah, my central AC unit died.
It didn't die during the winter. It died in the summer.
It died. It died yesterday.
Ay.
Yeah, and we had the service technician come out, and he did a couple of electrical tests and said, "Yep, the compressor is completely shorted out." So I'm getting a price for a new system. So if anybody wants to make a trip to Massachusetts and install a new AC system for my house, just let us know.
So the last rites were given, it sounds like.
Yeah, it's dead and gone.
Yeah. So anyways, I think you get a gist of the drag and drop. So very easy to put pictures onto the screen, and then you got the undo button, or you can delete or whatever. So I'm going to do a simple heating diagram and then we'll really take off with other designs and show you the flexibility of the software. So I put a boiler down here in the bottom right of the screen, and you can see the piping's heading this way. Well, I want it to head the other way. Well, I want to mirror this piece of equipment. So I right click on it and I go to mirror left, right. Notice when I right click, excuse me, left click, well, if right or left click on it, depends what you want to do. Some icons, it becomes, notice they're all grayed out where my mouse is in the top left here. When I click on it, now they become active, some of them. So I can click on this one. This says mirror left, right. So what I'm pointing out to you is there's a lot of functions that are available in different areas on the software. So whatever is easiest for you, okay? You know, I happen to think right clicking on it and going to mirror left, right is easier for me, but that's really up to you, whatever you get used to. Let me show you a default value and how to get the property boxes. This is very, very important with the software. Whenever I do designs for folks, I go to these property boxes, and I want to show you a chilled water design I did for a active chilled beam project. I did it last week for one of our reps up in Canada. If I double left click on this piece of equipment on the boiler, it brings up the boiler property box. Everything on the screen has a property box. The drawing itself, pipe, valves, everything on the screen has a property box. And to get to them, one way to do it is the double left click. But this is where the information allows you access to it. So, you know, where all the spreadsheets tied together, right? It's a bunch of Excel spreadsheets behind the scenes, I think. I can only imagine what the software package looks like behind the scenes, but they're all laid out pretty much the same, right? You got tabs or access on the left-hand side, and on the right-hand side is information for each of these tabs. And so here's a default value, right? This is what I call them. Other people may have a different name for them, but this says component head loss design. So when it does its calculations, it's going to include a 5-foot pressure drop through that boiler. All right, so I'm the designer and I say it should have a 7. Well, okay, I put in 7 instead, or 3, or 10, or whatever. So you can see that you can change that very, very easily. And notice component head loss actual. If we had actually used an icon for that air-cooled boiler and selected that piece of equipment, it would know the actual head loss and it would update the calcs to the actual. And I'll show you that when we finish the design and we start doing selections. I'll show you what I mean by that. And let's see, where is if I click on Hydronic, you'll notice component volume, and there's the fluid volume, right? Rich went over this last week about how important it is to calculate the volumes for your system, and I think many of you realize that for size and expansion tanks. Well, here's an example of how much fluid it has in there for your default value for your boiler. And again, you can change that by in this case, I can't directly change it because it's grayed out, so don't get frustrated, right? I'm typing on my keyboard right now, nothing's changing. I have to click in this box and give myself access to it. I'm not going to override any of the default values, but I did like to show you that that's something that's capable. Working fluid is also obviously very important for these designs, as Rich mentioned when he was talking about expansion tanks and the importance of if there's glycol in the system, put the glycol value in there because it makes a big difference on some pieces of equipment, namely possibly the pump and especially the TACO equipment, many pieces of equipment, but the expansion tank as well. So you can type and put in glycol as your working fluid. I'm not going to do that for this first design, but I did want to at least point that out. And you always want to do this at the generation equipment. You have access to do it at specific pieces of equipment, but if you do it at the generation equipment, what I mean by that is the boiler or the chiller or other generation pieces of equipment, maybe a cooling tower, that will find its way through the whole design, your whole design. Hopefully I'm not confusing you, but nonetheless, that's kind of important stuff. So I did want to at least show you the property box. I'm not going to go through any of these defaults. I'm just going to leave this alone. We have 3 tabs down here. Every once in a while, people ask what they mean. And here's a quick explanation. If you hit cancel, it closes the property box. It does not make any of the changes that you may make to the system, to the property box. So as an example, if I put the 7 here and I hit cancel and I go back to the property box of the boiler, notice the 7's not there anymore. But if I put in 7 and I hit apply and then cancel and go back to the property box, notice it still doesn't do that. So you need to hit, I thought that should have done that. I don't know why it didn't. Anyways, if you hit apply, it does put in that, that value, or you can hit OK and it puts in the value. So that's what those 3 are. Hit apply and OK, and you're in good shape, but you can just hit OK as well. Hopefully I didn't confuse you on that, because I just confused myself a little bit. Anyways, let's do a simple design. We'll represent 3 or 4 different pictures of different pieces of equipment. So I need to go from the boiler to some pieces of equipment here. Maybe I'll show some wings of a building, very small building for this design, because I want to give you the details of it before we really start having some fun using this software. So I know this all red icon here is an imposed load, pictures of imposed loads. So if I go to the terminal, notice you can represent buildings, and I'm going to pick a building later. Processes, you know, I don't see too many uses of that, to be quite honest, but maybe you might have some applications where you might want to pick out a spa or something like that. Most of the time you want to go get a terminal unit. So for my first picture, I'll get a fan coil. And watch this now. Instead of every time, the software remembers your choice. So if I wanted to get another fan coil, instead of having to click on the down arrow, go to choose fan coil, blah, 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 I could just click on that picture and it remembers it. But if I want to get a different picture, I click on the down arrow, terminal, and maybe I'll get a radiant floor a picture here, right? I can get a radiant floor picture. Or maybe I can get a coil. Maybe that's a unit heater or something like that. And we can change what these call outs here are. Notice there's other choices in here, panel radiator inline, panel radiators, fin tube, baseboard. So you have a bunch of choices of what you want your picture to look like. Or I can get other, and I'll show you why I'm getting another down there. Notice one of the choices is not air handler. Because in order to do an air handler coil design, you need to manually put that information in, because they have air handlers in on the air side. So that's a little confusing, but nonetheless, I'll show you what I mean by that in a second. I just need to get a sip of water. And it is just water, even though it's after dark. I am not partaking in any adult beverages yet. I'll wait until a little later. But
Hey, you know,
nonetheless,
Brett, a quick question popped up, and I don't think I know the answer to this. So Bill says, working in Colorado, does it have an altitude option? Does it have an altitude option? I know that you can select the city and it displays the altitude, but I don't know if it enters into the calculation at all.
all right, hold on a
It's on
second.
weather
Hold
data.
on a second. Hold on a second. Let's
I know you
go
can-
to Colorado. Let's go to Colorado and see what it does. Let's go to Colorado and see what it does. Ask William which one's the highest one. I know
So
Fort
what
Collins
city
is
in Colorado, Bill, would you?
Fort Collins is pretty high, I think. Right there, altitude.
I don't know if that it enters into the calculation at all.
That's a good question of
a
how
good question. Yeah.
we
Interesting.
will put that under. I'm going to make sure let's see what. So Rich, when we talk about the calculations from a hydronic standpoint, which ones would it actually have to work with?
It might have some effect on the. I mean, the altitude definitely has an effect on the net positive suction head.
Yeah, but that's if it's a
that's
closed loop system.
yeah, but that's a calculated value that's outside the system parameters. The only
Right.
other place that it might show up is the
Power.
is in the expansion tank. The parameters for an expansion. Yeah, put an expansion tank in there for a second.
It doesn't look like there's anything
Static
in
head
there.
above tank. Yeah. No, I don't think it. I don't think it. So I think the short answer, Bill, is that you can select the city and it'll put in the proper elevation, but I don't believe it enters into the calculation anywhere. But we'll have to ask the guys over at
Yeah,
HVAC.
great question.
Yeah, it's a good
It's 2 for
question.
2. Oh no, he had a comment and a question. That's it. He's 2 for
Yeah.
2. All right.
Okay. Good stuff.
Yep. So anyways, I've represented some pictures over here of different coils. So I want to override the call out. See, this says IHL-1 and IHL-2. So if I click on this bad boy here and I go to description, and again, it's grayed out, so I have to click in the ID box and I can do FC-A. Right. So now when I hit OK, it changes that to fan coil A. And then I can do, because it's a different one, I can do FC-B and whatnot. And then now notice the IHL, because I haven't overridden these, is now scooted down here, right? So the program keeps track of which ones it can, excuse me. We celebrated my mother-in-law's 97th birthday earlier this evening. At 97, you don't do two things too late at night. So I had some strawberry ice cream, Rich. Didn't you talk about a couple weeks ago? That was one of your favorites. I had some That's what she wanted for dessert, strawberry ice cream.
Yeah, strawberry ice cream is well. I can't eat ice cream anymore, but strawberry is my favorite flavor.
It was good.
Because when
anyways.
you get past 27, the food that you eat is very selective.
Yeah. 97. She was born in 1924. Imagine that,
1924.
Good God. I did the math today when I was out walking. I said 19.
Did anything significant happen in 1924? Maybe
My
the audience.
mother-in-law was born. Oh,
Yeah, but did somebody like invent something?
I'm sure somebody back then you could invent things because nothing else was invented, I guess. But anyways. So now maybe I want to call this RF for radiant floor. And, you kind of get the gist of it. This is all fine tuning here. Maybe this is a cabinet CUH cabinet unit heater, and I'm going to represent this as the DOAS coil or AHU coil. The heating coil that's in it, AHU coil. So you can kind of see how quick you can represent things there. And then to make the piping a little easier, I'm going to rotate this guy so it kind of squirts over so I can get the rotation a little bit. Obviously, this is, I'm just showing you some diagrams, different pictures to get you an idea what you can use here. And then if I draw a box around all of them and I make them all active, notice some more icons that become active here. And this one here with this solid green line, a line left, so I can line them up. So, us mechanical engineers, we like things to line up nice and neat and whatnot. And then notice I can name my project. I go back to this description, Taco After Dark -1, and then location. How about Cranston? Because I want everybody to realize that's where TACO's headquarters are. And we will be opening up soon for people to come visit us again. Well, soon. I say soon. It may be next year, but nonetheless, soon enough. It's quite a facility. And hopefully, I know some of you have been to the TACO facility, and we're very, very proud of it and what that team of for production folks have done during this pandemic has been just nothing short of fantastic, that's for sure. So now I've put my loads in here. I haven't put any values in here, but now I want to connect some piping, right? Very, very easy to connect the piping. This is the pipe drawing icon. So if I go up here and I left click on this broken arrow, it says connect 90 degrees. Boom, you can connect. You can connect at different angles too, but go ahead and do that on your own. I'm going to keep things 90 degrees. It's a little easier for me to figure things out. So you can get it that way, or if I go over to the boiler and I want to start drawing pipe, right? And I'm zooming in, and I just put my eye cursor right on the boiler little tab or that tab of pipe, and notice the cursor becomes that icon, right? And I left click and release, and there's my pipe. Bing, 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 bing. You can kind of see I'm playing with it here with my mouse, right? And I can just scoop back and forth. And every time I want to change directions, I just left click and release. Very, very easy to do, right? You don't node to node or anything like that. Very easy to do. And and every time I want to change directions, now I'm going horizontal, and I get over to where I want to tie it in, and I just left click. And then I can, boom, tie in these other coils here. Very, very easy to do, as you can see. Right, so that's my supply piping, and here comes my return piping back to my boiler. Bing, 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 bing. You know, left click and release, and you just scoot around. And like I said, it's very easy to do. And then obviously you got to do the remainders of here. And when we do classes, sometimes we actually do classes where the folks have computers sitting in front of them, and I hear the mouse clicking, and it's great because I know that's that they're doing it correctly. You just got to be careful sometimes. You know, you got to go to the ins and the outs and the returns and the supplies. You can get some dotted pipe. You just got to think it through. You see your connector arrows there showing you the flow direction. So, you know, sometimes you just got to be careful. And every once in a while, you're rushing. You don't get close enough here, and you click on it, and it doesn't go there. Oh, look, it just thinks I'm drawing another piece of pipe. So you just got to be careful as you go. The other thing I recommend is you save your file, right? So you save it as you start working on it. It's just always a good habit when you're doing this. The software does calculations very quickly, and usually it's user error. There's not many bugs. This software has been around for over 20 years now, so there's not many bugs in the software that cause it to crash. But usually it's like you'll have something connected wrong, and it's starting to do the calcs, and boom, it'll crash, and then you lose your file. So trust me, it's happened to me more than once. It reminded me back in college when I used to lose my files at 2 o'clock in the morning when we didn't have computers. We had to go to the, oh Christ, that was a long time ago. Anyways, just go up the file and save as, and TAD-1, Go After Dark -1. I'm just going to put it on my desktop and hit save. So now I can very easily get that file as you go. So now I've got a copy of loads here. If I, boom, I want to get a second column of loads, I just copy them and paste. So, you know, once you get the knack of the software, you can very easily make designs, and I'm going to show you even easier ways very shortly. But nonetheless, you can really make hay with these things once you get used to it, utilizing the software. So copy and paste. I mean, that's a big deal and whatnot. So now I need to put some loads in. I'll build my simple mechanical room shortly. And notice, once something's on the screen, you can still move it around. So like if I click on this piece of pipe, and I grab one of these little boxes here, and I left click and release, left click and hold, I can move that pipe. So nothing's fixed on the screen, okay? And this is how you add another sheet of paper. The software automatically does that. Hopefully you can see the dotted lines there as you scoot from one screen to the next. And then notice when I kind of goof around here, if I hit this zoom extents, it gets me back to seeing the whole screen. So I want to put in the loads. I'm going to put in these loads. Well, I'll do it one at a time. FCA, go back to key data. Maybe this is 120,000 BTU. So somebody has to do load calcs, estimates or whatever. Please, please, please do load calcs. Please do load calcs. Just a good habit to get into. That's all I'm going to say about that. And I'm sure Rich would emphasize that as well. But that's how you take that information that you have and put it into the software, right? I told you we needed that's a piece of information we need to put in as loads, right? I don't care if it's your baseboard, your air handler, your fan coil or whatever. You need to put the loads in BTUs per hour. And you notice I just did that. And when I hit OK, boom, it starts to do things. Wow, what happened here? I see red now. I see some flow showing over here. I see some values on the boiler. That's how quick it does calcs. So, well, I'm going to put the same value in here and show you how a shortcut. I like shortcuts, and if you learn how to use this software and you come up with other shortcuts, teach me. I love to learn shortcuts. I know a lot of them, but I love to learn. So now all of these loads, well, these two are the same. These two are going to be the same. And these two. Watch. All I do is click on this one. I want to put them in both at the same time. Hold the shift key down, click on this one, and then any other FCB that I happen to have, double left click, and it brings up both of them. And maybe these are 200,000 BTUs. I'm trying to make a big system just so we can get a good pump selection or a bigger pump selection. Here's a piece of friendly advice. Before you start doing something else, see how these two things are active? If you get ahead of yourself, deactivate them first. So I just left click someplace, right? And now they're not active. Then I can go over here and put these two in. I've overridden loads before because I start rushing, you know, and being careless. I guess it's more careless than anything. And boom, all of a sudden I overrun the loads, and you know, it's carelessness. Carelessness. That's all it is. Carelessness. So then these cabinet unit heaters. You know, I'm talking a lot here, but as I'm talking, I'm doing a lot of work here too, because I am putting these loads in as I go, so you can kind of see how easy that is to do. It is one of the more mundane things utilizing the software, but nonetheless, you need to do that somehow. You can globally do it if you're at the right time of a project, and I'll show you what I mean by that as we get going. So now all my loads are shown here. All the pipe is actually sized already. Well, let's display it. Here's how easy it is to display the pipe diameters, and we're going to look at how it does our calcs for pipe sizing, but all I want to do is activate the whole drawing. So one way to do that is draw a box, right? See how I just drew a box around everything, and you can tell it's all active now. Or the easier way to do it is hit Control A on your keyboard. Control All, Control A, right click, right? And you bring up all these choices here, connector annotations, diameter, and bingo, bango, bongo. There's all your diameters shown for your pipes instantly. Not instantly, but very, very quickly. So pretty straightforward there. So if you're in a presentation, you know, it depends where you are on a project. In a presentation, teaching people, maybe so we have some scholars on the line, you can start showing people how things are done very quickly. And like I said, we will look at the details of how it's sizing pipe very quickly as well. Let me build my simple mechanical room here. One thing I need to caution everybody: this software makes a big assumption, and that assumption is you know what the hell you're doing. What I mean by that is, do you suggest we pump away from the boiler or into the boiler? Well, this software doesn't care. It's not going to yell at you if you do it either way. So keep that in mind. If you put the expansion tank in the wrong spot, if you do something that shouldn't be done from a layout standpoint, it's not going to warn you, or you know, you still need to have that knowledge of how to do the design correctly. So please keep that in mind. So I'm going to add a pump. I'm going to get a little vertical inline pump. It's not little, but nonetheless, and I'm going to drop it on the screen. Now look, as soon as it turns yellow, the pipe, boom, and it drops right in, and it starts designing that pump for flow and head. No pipe lengths yet, but there are values for head loss for these pieces of equipment. And then I can copy this pump and put, excuse me, put a second one on. Oh boy. And very easy to do, as you can see here. And you can see these two are designed. Rich might have touched a couple weeks ago on parallel pump or whatnot, but in this case we have a standby pump, right? Pump 1 and pump 2, so either one can operate these systems. Then I'm going to do good practice here, and I am going to get a high efficiency air and dirt separator. This is an inline. It's R4900. It's a little different than what some of you may be familiar with, but I recommend it. If I was a consulting engineer, I would at least put it on my designs. And there's other folks that sell them out there, and I'm sure some of you already know who the heck they are. We think we have the best in the market. Wow, what a surprise! We think we have the best, but nonetheless, these inlines are very, very efficient. These coalescing air and dirt separators, and ours are designed to have a pressure drop of less than 2 feet. Watch what happens when I drop this in here. Boom! It starts to design that. It includes a head loss in for that pump. That's how quick it does the calcs, and then I can also get a we talked about different types of expansion tanks. I always like to choose I'll call it the Cadillac or the best one, and that's really the top choice there. That it's a vertical one, full expansion. That's the CA model for Taco. And watch what I can do with this. This is just kind of something you can do if you want. I want to put it down here. That's where I want to show it, but it maybe not fit down there. So I can just click on this and make the picture a little smaller and put it down there. And then I can tie that in. And it starts the size of the expansion tank with the default volumes that are in there. So you can see how easy it is to start making your design, right? And like I said, you need to know what you're doing, but nonetheless, it's pretty easy to do that. Let's look at a piece of pipe. So let's get into some of the meat of today's discussion. Well, not today's, but designers, right? What we need to know. If I click on this piece of pipe, key data, here's how it's sizing pipe. So it has a maximum unit head loss, and we have some presentations where we talk about how to manually calculate head loss, and Rich gets into the tables that are out there, and many of you may be aware of them. You may already use the wheel or whatever. Our competitor has a fine piece of paper, a fine piece of equipment out there, not equipment, but a tool that you can use. But nonetheless, it's all this information that's built in there, and then it has a maximum velocity. Personally, I leave it at 8 feet per second. I usually raise the maximum head loss. I think that's a little tight. But nonetheless, the velocity, I usually leave that alone. Some people can maybe fine tune it on a bigger system and maybe open it up for the big pipe and keep it smaller on the smaller pipes or whatnot. But I do know personally, my recommendation is to keep the velocity in pipes. Actual velocity is shown here below that 8 feet per second, and you won't have any noise, vibration issues, and the wear and tear on your equipment won't be as bad. And the grandmother that's in apartment 602 won't complain about hearing rattling or water flowing or whatnot. So nonetheless, that's my personal recommendation. But nonetheless, it uses this flow rate, these values here, and it selects that diameter of pipe, and it displays it right there. Pretty straightforward. Not too much, not too many surprises there. So that's what it does for pipe sizing. Lengths of pipe, right? So let's start putting in some lengths of pipe here. And we'll talk about fittings, right? That question always comes up. So I'll go back to this piece of pipe, key data tab, length. It's already asking for length here. So maybe I'll put in 300 feet, right? I'm putting in some values here just to get some good head loss. And here's what it uses for a fitting factor. Not unusual in our industry for some estimates here. Although Rich and I, we've talked about this offline before. When we first started, we designed piping systems where we calculated the head loss. We counted every elbow and every twist and turn and tease and everything it went through for the longest run, the worst case, and calculate it that way. But nowadays is kind of globally accepted using a fitting factor, and you can see here's the pipe head loss for that 300 feet of pipe at that flow rate. It's calculating a head loss of 7.8 feet. Well, it's going to multiply it times 1.5 and give you a total head loss of 11.7. So that value, let's do some quick math. Rich is a heck of a lot better at quick math than I am, but I am adding a 32 plus 11.7 at 43.7. Please come up to 43.7. Please, please, please. Ah, good. It did. So it came up to 43.7. So it's including 300 feet of pipe length for that piece of pipe, and a head loss of that value right there. And then you can start putting in values for other pieces. And I'm just going to put some in here just to get some other values in here. I don't know why that came up. Why did it? I'm trying to hit that piece. Just so I can get some pipe lengths in here. It is one of the more mundane pieces of components, but nonetheless, you do need to put in pipe lengths and make sure you can get take care of that as you go through things. So I just keep that in mind. And then if you want, if you think about that example, you can display some of your lengths, connector annotations. You can display a lot of pieces of information here, but notice I can put in lengths here, and I can change, override that font, make it a little bigger. So, so you can keep track of it if you'd like. What would be a good color? Well, I guess I'll just use red. Nonetheless, that pipe length, and that pipe length is just this piece right here from here to here. So you just gotta keep that in mind as you go. And then you can add other pieces of equipment. If I go to the hydronic tab, I can add a control valve, right? So if I go to, and there's some manufacturers of control valve here, but I'll just put one on. Notice the software flips it for you automatically. Boom, puts it in there. I can add some shut-off valves, another shut-off valve. You got all, I mean, if you remember the examples that we had, you can see all the details there, and maybe a balancing valve. You can put that in here, and really that's up to you. You can add a note if you'd like. So you have all kinds of flexibility there as you'd like. Some stuff to consider as you go through things there. If I click on the pump property box and I click on show head loss path, it actually shows you the worst head loss, and that's actually going through this little radiant panel here. So that's your worst case. So that's where that 47.3 that value comes up. And if I click on the summary tab, it actually shows you those values over here and everything that's going through. So that's the default. That's why it's going through this component, because the default value for that imposed load is actually 15 feet, and all the other ones is 5 feet. I was wondering why that. I usually don't put radiant panels on here. But it kind of makes sense, right? Those panels do have a little more head loss, so that's why that head loss is through there. Hopefully everyone understands that pump head loss is for the worst case, right? It's not additive for every case. It's the worst flow path in your design. So, that's something that you need to make sure you understand. And that's another whole discussion that we don't need to get into, but that you don't add up every head loss for every component for that. It's the worst case. And this is a nice little picture. Rich and I like to use this. I look at it all the time when people send me designs. Just, I want to make sure these values are pretty accurate. So I think I've kicked that to death. Any questions on this stuff, Rich, so far? Any more?
No, we don't have any new questions, but if you guys are, if you have something you'd like to ask, you can type it in. We'd love to.
Is everyone sleeping tonight?
I think so. I think, well, you know what it must be? It must be warm all over the planet and everybody's kind of snoozing.
Yeah. Okay, well, I'll keep going.
Yep. Nathan says he's already asleep. He's got some Z's here.
There you go. Oh, I'm that boring, huh? Well, let's go have some fun. All right, so I'm going to pick it up then. I'm going to pick up the pace. I'm going to double left click on the pump, go down to selection, hit select. It's selected a pump. I hit OK, and bingo, it's selected that pump. You can already see that. All right, I can globally select some pieces of equipment up here, and watch that shading goes away. And notice this head loss changed a little bit. And if I click on the air separator, it went from 3 feet. It went from 3 feet to 3.7. So that's why it went down a little bit for that pump. Now it's selected the equipment that's selectable, so I can create some files. If I double left click, bring up the project property box, scroll down to coordination file options, click on it. Here's your files that you can create. I am not going to save it to AutoCAD because my computer's DXF file's not working in my viewer, but I am going to do a, let's see, I'll do it in Excel, bill of material and equipment schedule in Excel. Notice you have other formats here. And then all I have to do is save my file, save as, hit save, and yes, I want to, boom, that's how quick the software creates the file, those files. So now I'm going to go to open coordination file, bill of material. There's your bill of material and called out there, and you might have to adjust some of that as you go through there. You can put some pricing in here and whatnot, or you can open up your equipment schedule, and there's your equipment schedule. So it can create these files for you very, very quickly, and everything is shown down here at these tabs at the bottom. Oh, guys, look at the pumps. There's a couple nice KS 3007s, only 5 horse. Questionable whether you need a split case on that, but that's for another whole discussion. Talk to your rep about that. Personally, I might go with a KV and save a couple of bucks in my design. So that's how you create a design manually, right? One at a time. Well, let's have some fun using the wizard. So I'm going to go over to the get another sheet of paper, and I'm going to go to wizard. What's the wizard do? Watch this. Well, before I create a whole system, let's go create a generation system, generation wizard. So let's go cooling only. Hit next. Let's use, for the first one, an air-cooled chiller. Hit next. Let's put in maybe 3 chillers at 50%. And I'm, all right, let's put in some glycol on this one because it's a chiller. Probably, maybe we might use some glycol. 30%. I left it at 30% a percentage. You might have to change that, right? That depends where you are. Manifold, primary. I'm going to do one of each just to show you the difference of them. So let's manifold primary. Hit next. I'll put in a couple of pumps. I like the verticals. Well, you know what? We did a vertical. Let's do a frame mounted end suction. That's our FI pump. Hit next. Some valving. Hit next. Glycol feed. Hit next. Expansion tank. By the way, if you ever make a mistake on the screen, so I'm going to change this to 0. Okay. You know, so I don't want an expansion tank. Well, the software says, you need to correct your screen. So if you ever answer a question incorrectly, or if you ever see this grayed out down here, you answered a question incorrectly. Hit next. Air separator. Hit finish. And there's my my design, right? With my 3 chillers, each one at 50%, right? So I've got two with a standby. I've got a couple of pumps here, my primary pumps ganged up, so either one can operate both chillers. So let's look at the next design here. Let's look at another one, right? Hydronic generation wizard. It remembers all your answers. So instead of manifold primary, let's do primary and hit next. This time we'll use a vertical. Notice the difference here is now we just have primary pumps. So each pump is attached to the chiller. All right, so that's I'm kind of showing you some of the differences that you can get involved with here once you use the wizard, or you can click on Hydronic Generation Wizard, hit next. Whoops, I didn't change the question, didn't change it. So let's do primary, secondary. I'm not going to use this hydraulic separator. I might on another design as we get going here. As we go, and you can see this one here is primary, secondary. So each chiller has a primary pump, and then you have your secondary pumps going through the building or loop, right? And I used F5 pumps for these. You can see the difference in pictures, but see what the generation equipment can do. See what the wizard can do. It can do your mechanical room design for you very, very quickly. So there's just something to consider there. Different ways to use this software. I'm deleting a couple of them just so I can show you something else. So think about it, right? If you're using, if you're in a discussion with folks and you got some questions, or you want to do some talking, but you haven't done a lot of design, but some people have already told you maybe how big the building's going to be. Well, if I go back to Hydronic tab, I go over here and I get a picture of maybe building. I'll get a hospital, just a picture, right? And then I connect it. Connect it up, right? Just a picture of my building load. I connect it up here. See right here, I missed it, so I got to be careful when I connect it up. Then I go down to this hospital, go to the key data. I have to go to summer, and maybe this is a a pretty big size hospital. Boom, there's your design, right? You hit Control A, right click, connector annotations, diameter, all right? And you can start saying, okay, well, our mechanical room's gonna have 10-inch pipe, and you can start talking to people, maybe start figuring out the pads, talking to your chiller people, but just something you can do from a display standpoint, or early in the project, or whatever. I'm just trying to give you some ideas of how you may be able to use this software very, very quickly as you start thinking of different ways you can use this software. So pretty quickly when you can use the wizard to do something like that. Let me get another sheet of paper and let's do a complete design. But before I do that, I'm going to create, let's see, where is it? Print. I'm going to make my sheet of paper a little bigger. And instead of a little small sheet, I'm going to actually and this is how I do it on my computer. I'm sure there's different ways that you smart people can do it on your computer, but nonetheless, now I have a D-size sheet of paper because I'm going to do a complete design and I want it to show up on one sheet of paper. So all I did was go to File, Print. I brought in my printer for the PDF, print to a PDF, and I changed the paper size doing it that way because my printer that's tied to my computer or defaults to it doesn't have a bigger sheets of paper. So I go back to the wizard. This time I'm going to click on Hydronic System Wizard. All right, and I don't want to open a file. I'm going to create my own. And let's create a direct return. Maybe we'll do a heat pump project, right? So we did some chilled water. We did some hot water. We'll do a couple different ones. So this is heating component and a combined schematic. And notice it's changeover 2, but I'm talking combined schematic. That's what a heat pump is. For some of you that may not know out there, a heat pump design allow the water can flow into a heat pump and it can heat and cool. It can heat the room A and it can cool room B, but it's the same water going in for the most part, right? And that's what a heat pump allows you to do. It has so hit next. Number of loops. Well, let's do a 6-story building, right? 6 floors. I'll do horizontal distribution for this one here. And I'll put the mechanical room up on top, right? So see where it says build direction down, the mechanical room top left, hit next. Number of loads, well, let's just put in 12. All right, so I'm gonna put 12 loads in on each floor, just to make something up here. And I'll show them below the piping. You can show them above or you can show them alternating. So alternating means there'd be one above and one below. So in this case, there'd be 6 above and 6 below. Hit next. I'm going to use this data for the remainder of loops. Hit next. I want to use a heat pump. And notice there are some choices of manufacturers in here. And so that does give you the capabilities of using different choices there. Hit next. I'll put a 2-way control valve on the heating. Notice it doesn't give you an option on the cooling because the heating and cooling are the same, right? The heat pump's doing both the same things there. Let's just type in HP, and maybe these are 2-ton units. It does have a coefficient of performance and an EER value down here. Head loss design, it's a little high for heat pumps, and the delta T is a little low, so you may want to look at changing some of those values, but nonetheless, they are displayed there for you. And that's important to realize. So I'm going to do it with a boiler and a pretty straightforward system in a cooling tower, all right? Pretty straightforward. Not going to put a storage tank on there, but you have that option to do that. Maybe I'll put a couple of boilers in there, you know, and size them a little less. Usually for heat pumps, you don't need them all sized up there. Hit next. Cooling tower, I'll just leave it at 1. Maybe I will. I'll show you how to add a heat exchanger at some point. I'll put this on primary, secondary, and this time I'm going to use a hydraulic separator. This is a Taco design that takes the bridge out of the play. So closely spaced tees, decoupler, whatever you want to call it. We have a lot of names. The industry has a lot of names for it. We have a piece of equipment. It's our 5900 that can actually be designed right into the project as well. And so maybe I'll put this as on manifold primary. So the tower pumps will be the building or loop pumps. Trying to get as basic a design as I can here. Hit next. Primary pumps, vertical inlines. Those are my favorite. I try to specify those as much as I can nowadays. Excuse me. Secondary pumps, maybe I'll put in 3 again at 50%. Put a suction diffuser on that. We did talk about some of the benefits, and we see more and more people specifying verticals. And Rich talked about that a couple 3 weeks ago. So I'm not going to get specifically into those details anymore. Hit next. Expansion tank, air separator. Hit next. Not going to save this file to the wizard. Hit finish. Doot, doot, doot. Thought it wasn't going to come up, but it did. All right, so let me just make sure I put it on the screen. Come on now. It's not actually going to fit. There we go. I'm pretty happy we're at that location. Here's something I recommend as you start working on these designs. When you start getting up there with loads and values on your screen, put the software in manual recalculation. What that does is it doesn't. The software is very quick, or it can be, and it tries to do all of the calculations each time you make a change. So I won't say you overwhelm it, but when you have a lot of loads on there, it slows it down. So if you put it in manual recalculation, it won't redo the calcs each time you make a change, or add a piece of equipment, put in a pipe length or whatnot. So that as systems get bigger, as your design gets bigger, I do recommend you put it into manual recalculation. So here's my six-story design, and this is what I like to do. Notice I have 4 of the stories in the mechanical room on one sheet of paper, and then the other 2 on another sheet of paper. So then I could add notes here, if I ever use this on my MEP, I can say connecting to sheet 2 and vice versa there. So keep that in mind. I can hit Control A, right click, connector annotations, diameter. Software is a little slow tonight. Or it might be the user, because he gets slow too as things go here. So if I zoom in, you can see all the pipe diameters displayed for you. Your heat pumps are shown. Your mechanical room is starting to be designed. You got to add some pipe lengths in there. There's that hydraulic. That's 5900 we talked about, the hydraulic separator. And so it's really starting to design your heat pump system. And what the software does, it actually shows you these values down here, worst case for cooling, worst case for heating. So it doesn't show you, the combination, it shows you worst case. So that's what it does. It does all the worst case for heating and all the worst case for cooling. And if you think about it, that's what us engineers have to worry about, is worst case. So there's a quick design. for you utilizing the heat pump design there. Rich, I need a break. Any questions? You got a funny story?
Actually, Sarah asked if I would tell everyone about the egg recipe.
Oh,
This
I
would
want
be
to
a
hear
good
that.
time for that, don't you think?
Yes, it would, because I
Get
need a
people
sip of water.
thinking about stuff. There is an engineering application, but I'll go to the eggs first. So, Sarah, are you still out there? Are you still listening to us? Because if you've already left, I won't waste everyone's time talking
Oh,
about. No,
Sarah's
she
there.
says, all right. So, how to make perfect hard-boiled eggs? Well, let's assume that you're at sea level because it will make a difference. So let's say you're going to make a half a dozen eggs, and you want to make hard-boiled eggs. So this is what you do. You get a pot large enough to have the eggs for boiling in boiling water. So then you put that pot filled with water large enough for handling, say, 6 eggs, and you put that on your stove and you start to heat up the water. And then the second thing you do is you get a bowl, just a large bowl, and you put it on your kitchen counter, and you put the 6 eggs in the bowl. Usually people keep their eggs in the refrigerator, but you put them in the bowl because you want them to come up to room temperature. And then in a separate bowl, so far we got three things. We got a pot of water sitting on the stove ready to be boiled. We've got a bowl, just an empty bowl with eggs in it that are warming up the eggs to room temperature. And then the third bowl, we want to fill that with water and put ice in it, ice cubes.
That's in case you burn yourself?
It could be, but no. Okay, so let's assume that you've let your eggs heat up to room temperature, and let's assume that your pot of water is boiling and that you're at sea level. And the reason you're at sea level is because the water is going to boil at roughly 212 degrees Fahrenheit. So now you get a timer, and I use my iPhone when I do this, and I set my timer for 14 minutes exactly, 14 minutes. I take the eggs and I put them in the boiling water and I press the timer, and immediately it starts timing how long it's going to boil. And I've set that for 14 minutes. Now, at the end of the 14 minutes, my timer goes off, beep. I scoop the eggs out, be very careful because they're very fragile at this point, and I put them very carefully in the bowl of ice water. And I put all 6 eggs in the ice water, and I let them sit for roughly 10 minutes maximum, 10 minutes maximum. And now I can take them and I can bring the ice water over to the sink, and I can run cold water and can peel the eggs. The eggs will peel very, very easily and very quickly. And after you get all the eggs peeled and all the shells off, if you happen to cut one of those eggs, you'll see that they're perfectly hard-boiled and they're all uniform, nice yellow color on the inside. And so that's how you make perfect hard-boiled eggs at sea level. Now, the thing is the higher the elevation is, the lower the temperature that water will boil at. And so you have to know, you can have to adjust the timing. So if you're in Denver, Colorado, for example, you're about a mile or so above sea level, and you have to boil the eggs for roughly 15 minutes instead of 14 minutes. You might have to experiment a little bit because that 14 minutes works perfectly at sea level. So that's it. That's how you make perfect hard-boiled eggs. And as far as the engineering application is concerned, there's a relationship between the temperature at which water boils at and the atmospheric pressure. And so water will boil at 212 degrees Fahrenheit at sea level, and it'll boil at a lower temperature in Denver, Colorado. And that's because the atmospheric pressure is lower the higher the elevation. And when you're designing pumping systems rather, and if that pumping system happens to be open to the atmosphere, typically for a condenser water system that has cooling towers that are open cell cooling towers opening to the atmosphere, it depends on the elevation, will depend on the atmospheric pressure, and that enters into the whole calculation that you do for available net positive suction head. So the eggs and the net positive suction head have a relationship, but the formula that I gave you, or the recipe for making hard-boiled eggs is real, and I do use that all the time, and I happen to make perfect hard-boiled eggs. It's not my recipe. I downloaded it from the internet, because my hard-boiled eggs were never coming out all that well, and I always had difficulty peeling them. And when I tried this one, it comes out perfect. So hopefully you'll be able to make hard-boiled eggs. So if you've learned anything this evening, you've learned a little bit about HSS software and a lot about boiling eggs.
Couple of comments to that story, Rich. Number one, I have used that formula on numerous occasions, and it works perfectly. So I can attest to the timing. You know, and obviously the chilled water thing, give or take a couple of minutes, but nonetheless, the very first time I did it, I used that 10 minutes. It worked perfectly. The 14 minutes was probably the important one. But the most important thing for me personally was peeling the eggs. Because
Peeling
I
the eggs,
always
yeah.
had problems peeling the eggs. And the this formula and peeling them under running cold water, it work. The eggs shell comes off lickety split, and it doesn't tear up the egg. It doesn't stick to the egg. Oh, it works great. It works great.
Yeah, and if you like hard-boiled eggs like I do, you have trouble getting all 6 done up because usually halfway through the process, I eat 1 or 2 of them, so, which
I
is
like.
not a good thing. And, you should wait. But I've tried to do a half a dozen at a time because we'll make egg salad out of it and put some in the refrigerator and take a couple on a cooler if we're going to go for a little drive in the car to take the dog for her special walk. It says it also helps to use older eggs. They peel easier. Well, that's good information. That I did not know. So yeah, Bill
Well, how the
said,
heck do you know if it's old? You buy it and let it sit in the fridge
yeah,
for two
maybe you let
weeks.
them sit in the refrigerator for a week before you use them. We get, I don't know if you are, Brett, but, oh, Nathan says you can float test the eggs. Bill says he's got chickens. So is the float test a good test for the,
Oh yeah, if it floats, you throw it away. That's what I do. You
because
don't
they're
want
old?
floating eggs. That's not a good sign. Is that true? Bad
Bad
eggs
eggs
float.
float. Oh, okay.
Yep.
I didn't know that. Look at all the
Yeah.
stuff I'm learning.
Yeah.
But
My
my neighbors have chickens, so we get fresh eggs, literally fresh.
my my daughter, my youngest daughter, who has a 20-month-old son and who's also due in October for with a daughter, uh, uh, just got 12 chickens. So now they got a chicken coop with 12 chickens. So
Wow.
she's a loony bin.
Are all the chickens laying eggs? That's a lot of chickens.
No, she got them as little chickens. So I think it takes 6 months. Maybe Bill can confirm this, but it takes at four to
What are
six
young
months.
chickens called? Just chicks, or they call them chicklets? I guess that's
Uh,
gum.
I don't know. She got 3 different kinds, and they're all females. I said, "Do they get along?" She says, "The trick is to get them all when they're little, so they think they're all the same."
Oh, no kidding.
Oh boy, let's get back to having some fun here. So we designed a heat pump system. We used the Wizard. What else should I show them, Rich? You got any idea? I mean,
Well,
how about this?
actually, let's do this. Is this a glycol system that you have here?
I did
No,
not.
I don't think so.
No.
No, it's water. Okay, yeah, because you have a cooling tower. So here's one of the things that we want to make sure we tell everybody. Zoom into this little puppy right here. And okay, so this assumes that it's a closed cell cooling tower because it has an expansion tank.
Right.
And if you notice the diagram, Brett used the Wizard. There's no detail for makeup water. So the Wizard gives you about 75% of the pieces and parts that you need in a system, but the other 25, to 30% of the information, you have to get it from someplace else. And Brett is showing where you can get a detail for a makeup water connection, and you can copy and paste it. But the point is that, and I think, Brett, you made this point earlier, is that you really need to know something about designing HVAC systems, because the software does not do 100% design for you. It does about 70% of what you actually need. And you would have to provide additional information, like in this case, a makeup water you'd have to provide maybe more information about where you wanted isolation valves. For example, there are no isolation valves for the cooling tower. If you zoom in a little bit. So, you know, the software is extremely powerful, but it does assume, the assumption is that you know a little bit about what you're doing, and you know, you need to add enough information and notes and details to make it a viable design. So that's an important piece that
Yeah,
because this actually came up about a week ago. One of our customers, one of our reps actually did a really nice hydronic system design and sent it over as a concept to the engineer. And the engineer literally cut and pasted, put it on his drawings, and went out to contract. It went out to bid and contract. And the contractor installed it exactly the way it was shown on the drawings, but the several pieces were missing. The system couldn't possibly operate. So yeah, you can't take the drawings that the software generates verbatim. You have to look at the details.
I'm opening up a design I did recently, Rich, and you may recognize some of this. This is the project that we talked to Darren McPherson about.
Oh yeah.
So here's another way that the software can be used. And notice one thing I did was I have two different. I have it on two sheets of paper. So this is a riser diagram, and I'll zoom in so I can explain. So this is the hot water, as you can see, and this is the chilled water over here. And then each of these block loads represent a floor, represent a level, floor, level, whatever, as well as some DOAS units. There's going to be some separate DOAS units out there. So this gives the engineer or the team, the designer, the size of the risers, right? So here's all your riser sizes, right? So, you know, hear me out, hear my thought process out. Now, if I go back to this opening, I can go to level 1 cooling, and I open that diagram. So here's my level 1 cooling diagram. So let's just hear me out. So this would be the risers, right? The riser connection would be this right here, and this is where it comes out into the floor. So I have a 2-inch run. This is a load match system, so it's single pipe, and we can get into that discussion. So here's my single pipe run going around level 1, and this load is the load I put in on the block load for level 1. All right, so then I can go to, I have one for level 2. Bear with me, it'll get a little neater in a second here. Level 1, 2, and 3 are commercial, so they're not that big. Bear with me. So these are levels 1, 2, and 3, right? I'm not saying they're that big, but they're all fan coils for the wellness center, some fan coils for the elevator area in the washrooms, and other pieces of equipment, some offices over here. But now let's look at this other level here. So this is level 4 to 13 cooling. So each one of these levels is the same. And look at that, I didn't save it. Oh wait, that's the wrong one. You got to get. Sorry about that. I should delete that one. It's 4. I had that one. I'm going to delete that right out of here. It's 4 to 14. So here's our low flow design with chilled beams. This is actually a chilled from levels 4 to 19. They're actually using chill beams in the zone. So again, think about the risers coming up, and this represents the risers. I need to put in a chiller here so it can do the calculations. And as I can see here, it says shown for calculation purposes only. And this is where it comes out of that. There's a pipe chase there, right? So the two risers come up, and this is where it goes onto the floor. And then I have my single pipe that goes around, and this is our low flow block that's mixing the water temperature at each zone that has a chill beam. And then some of these zones may have more than one chill beam. This is very early in the design. We were trying to get some initial pricing to it, but this was the thought process that we worked on. So this floor here is from 4 to 14 have all the same design, right? Not unusual, right? Many floors on some systems, some projects have the same layout. So that's what this represents as you go around. And then I can open up the last one. I'm just trying to give you some ideas, and we have the same thing. I have the same thing for heating, right? I have the same thing for heating. In this case, we didn't use chill beam. It was only a 2-pipe chill beam. It only has cooling. It doesn't have the heating. 15 to 19, I hit OK. So now each, and then I have to, when you get up a little higher, the floors change, right? Instead of having a big rectangle, now it pinches in a little bit, so there's not as many zones. But these are the upper floors, and they're actually trying to rent these out. Anyways, you have to get into the narrative of the project. But so you can kind of see how instead of putting all this information on one sheet that would just drive you crazy, I broke it into floors, right? I broke it into first, second, and third floors, and those are the businesses, right? Not unusual, the retail or the common areas, the wellness center, and maybe libraries or whatever's down there, and some stores, a restaurant, and whatnot. And then 4 to 14 are all the common offices, and 15 to 19 are some other rental offices or whatever. So a different way to use the project, but nonetheless, once you understand that, you can kind of see in that now. So this shows you what pipe diameter you need on each floor, the runouts, boom. People can start pricing it up very quickly and understand it. Does that make sense to you, Rich? Did you kind of follow my thought process there?
Yeah, I think it was a great way to represent the system schematics and concept too. You know.
I mean, it's very early, right? I mean, the information that Rich and I received on this project was, and many of you have been through this, right? I don't know how many times it's early in a project, but people want some pricing, some information. Well, you know, you get a little nervous sometimes when you start, unless you're as old as I am. Oh, that's not true. Maybe Rich. No, that's not true. Others and have maybe a little more experience, but still, it's nice to have some technical information behind the scenes to make you feel a little more comfortable. Now you know, okay, what do I have here? I have a 10-inch riser, maybe goes to 8-inch. I'm coming down. I know the stuff's up on the roof. I've got my plate and frame heat exchangers. My towers are outside. I'm in Canada, right? I put some pipe lengths estimates in here. You can start getting some rough estimates for the design. The heating is more I forgot the heating was. He was going to do ceiling panels, I think, if I'm not mistaken.
Rated healing panels in the ceiling.
Yeah. So on
But Brett,
the outside,
we're actually a lot of folks are starting to drop off, so I think we should try to wind things down a little bit. Do you have any last minute things you want to tell everyone?
No, you know, I just want to thank everyone for their time. Hopefully you got something out of it. Feel free to email us if you have any questions using the software. It's pretty easy to pick up. After presentations like this, it's not unusual for me to answer questions directly to people. But thank you for your time, and take it away, Rich.
So here's what we're going to do. I'm looking at the list of questions, and Bill was the last one to actually post something. And if I don't get any questions in the next minute or so, we're going to sign off. But if there are questions lingering out there and you'd like to ask them, we're going to stay and answer whatever questions that you might have. So this is their opportunity to ask some last minute questions. Like I said, if I don't see anything in the next minute or so, I'm going to sign off.
How about
saying thanks at this point? So
how about the history of TACOs? Anyone want to learn about the history of TACO? How about this? There's Elwood White founded it or purchased the thermal appliance company. I guess I didn't realize that, Rich. He actually purchased the company in 1920. So we say founded it, but nonetheless,
yeah,
in New Jersey. But anyways, maybe not.
Nathan says he'll keep talking only if actual tacos are involved.
Hey, and margaritas. That's true.
Margaritas.
Well,
yeah.
At least his Z's aren't up there.
Yeah.
moved a lot quicker. So anyways, thanks
Well,
everybody.
listen, at this point, I am going to say thanks again. Thanks, Brett, for a great discussion, a great presentation. Hopefully, we very much appreciate those folks that have, uh, that have joined us and participated. And hopefully, you'll stick with us. We're planning, I don't think we've published anything yet, but we're planning to do some more in the fall. Is that correct, Brett?
I believe so.
Yeah.
We'll see. We'll see if the other folks give us an opportunity to do these again.
Yeah.
But hopefully we can.
I think there are, but aren't there already the residential focused Taco After Dark? They're already scheduled, right?
Yeah. They start back up next week, as far as I know.
Oh, good, good.
I
Well,
haven't.
with all of
Yeah.
that great stuff, I am going to sign off in a few seconds and say my last thank yous. Thanks, Brett. Thanks, everyone out there for participating. Have a great night, and we'll see you next time around, as they say. So good night, and have a great evening.
Bye, everybody. Thank you.
Bye-bye.